Hey everybody, we're live and in stereo. So if you look at question 16 and exam question 20, but our question 16, it says X is a group 2 element in either, I've shared the screen, right? X is a group 2 element in either period 3 or period 5, and its XOH twice is less soluble in water than calcium hydroxide, okay? When X nitrate is heated, it decomposes. Which row is correct? So it can be in period 3 or it can be in period 5. Let's talk about it. So where is my periodic table, sir? Where's my periodic table? So period 3 is this right here, and period 5 is this right here, and it's group 2. So he's saying it's either what? It's either magnesium or it's strontium, right? So between magnesium and strontium, it can either be magnesium hydroxide or it can be, if it's period 5, then it should be strontium hydroxide. But the problem is, he's saying that it is less soluble in water than calcium hydroxide. Calcium hydroxide is in the middle, and you know that the solubility of hydroxide increases. The solubility of hydroxides of group 2 increases down the group, right? It increases down the group 2. Down the group 2, it increases. So strontium hydroxide is more soluble than calcium. Barium hydroxide is the most, then strontium hydroxide is more soluble than calcium hydroxide. But he's saying it is less soluble in water than calcium hydroxide. So strontium is incorrect, because obviously strontium is more soluble. Strontium hydroxide is more soluble. It's saying it's less, it's whatever hydroxide you have, it's less soluble compared to calcium hydroxide. So it must be magnesium hydroxide right here, because he's saying it's period 3 or period 5. So it's either magnesium, strontium. Strontium is wrong. Now magnesium. Now I think when it decomposes, when the nitrate of X is heated, it decomposes. We know when magnesium nitrate is heated, what forms? Magnesium oxide, metal oxide plus nitrogen dioxide plus O2. And how do you balance this? This is a 2, this is a half. So where is the half here, you dumbo umbo? A is wrong, B is the correct answer. Why? How is B correct? Said B has 2, 2, 4 and 1. Well, if you want to remove this half, you can multiply the entire equation with 2, and you're going to get 2 MgNO3 whole twice gives you 2 MgO plus 4 NO2 plus O2. This is what you will get if you want to remove this fraction right here, this fraction. So that's the idea. Done? Next. Which statement comparing magnesium and barium or their compounds is correct? Again, magnesium and barium. I have to be very careful. Magnesium and barium is here, right? So I have to compare magnesium and barium. Magnesium is at the top and barium is right here, somewhere at the bottom. Now he's saying which statement is correct. Okay. Magnesium reacts with dilute hydrochloric acid more rapidly than barium does, and that's absolutely incorrect. Why? Because down group 2 the reactivity increases, because you know for metals reactivity has to do with what? Reactivity for metals is how quickly they can lose electrons, and you know that down the group the size actually increases. The larger the size, the more the distance between the outermost electron and the nucleus, and therefore what happens? You have more shells as you go down the group, larger atomic radii, right? And what happens? The ionization energy decreases, so you can easily remove an electron, pluck an electron. Ionization energy is lower, that means reactivity is higher. So barium is more reactive than magnesium. So wrong. Barium is going to react more rapidly. Okay, if you look at B says 1 mole of magnesium carbonate gives off greater amount of gas when it reacts with excess hydrochloric acid than 1 mole of barium carbonate, and the answer is, you dumbass, the examiner, both give the same volume of gas. Both give the same volume of gas, because if you have magnesium carbonate and it thermally decomposes, it will form magnesium oxide plus carbon dioxide, and if you have barium carbonate and it thermally decomposes, it forms barium oxide and carbon dioxide, and both are going to give you 1 mole of carbon dioxide. So both volume of carbon dioxide is equal, sir. It's not greater or lower, right? And then the next is the solubility of magnesium sulfate in water is greater than the solubility of barium sulfate in water, and that's true. Barium sulfate is insoluble in water, because you know solubility down group 2. What happens to solubility down group 2? It decreases for sulfates, increases for hydroxides, and decreases for sulfate. And we've seen it. Barium sulfate is a white precipitate, right? Magnesium sulfate is soluble. So that's actually correct. It's saying the solubility of magnesium sulfate is greater. It is greater, right? That's why barium sulfate forms as precipitate, but magnesium sulfate is soluble. So C is absolutely the correct option, right? And it says magnesium carbonate undergoes thermal decomposition less readily than barium carbonate does. This is incorrect. Why? Because if you look at magnesium carbonate and if you look at barium carbonate, their thermal stability. What happens with thermal stability? Thermal stability increases. Stability increases down the group. Stability increases down the group. And if stability increases, you know that you can easily decompose this fella. You can easily decompose this fella because it is less stable thermally. It's less stable, easily decomposed. Whereas barium carbonate cannot be easily decomposed because it is more stable. Stability increases down. Thermal stability, or maybe even the stability of nitrates, thermal stability of carbonates and nitrates increases down the group. So it requires more energy for you to thermally decompose barium carbonate compared to magnesium carbonate. So it says magnesium carbonate undergoes the thermal decomposition less readily. No, more readily. It's less thermally stable. Less stable means you can break it easily. Less energy would be required to break it. And I've also given you guys the reason for it, which is not a part of your course. You'll study that in A levels, but A2 level, which is magnesium ion is much smaller, so it can distort the carbonate ion, and therefore you could easily thermally decompose it. It's less stable thermally. So yeah. 18. The colors of silver halide AgCl, AgBr, AgI differ. The solubilities of these halides in aqueous ammonia also differ. Which row is correct? Now, in aqueous ammonia, you know, if it's chloride, bromide, and iodide, right here, I'll write it like this: chloride, bromide, iodide. If you have dilute aqueous ammonia, what happens in dilute aqueous ammonia? This is soluble, and in conc ammonia, it's also soluble, right? This becomes insoluble in dilute, but in conc it's soluble, and this is insoluble and insoluble, right? And this is cream PPT, this fella right here. This is white PPT, this fella right here, and this is yellow PPT, right? So now he's saying color of AgBr is not yellow. Yellow is AgI. Silver halide, that is the most soluble in aqueous ammonia. Well, which one is the most soluble in aqueous ammonia? It's this chloride ion right here. So it's AgCl, which is the most soluble in aqueous ammonia. Done? Yeah. Moving forward, it says, question 19 says, the name chlorate is used for an ion consisting of chlorine and oxygen only, right? It's like ClO minus, that's the chlorate ion. It can be ClO, 3 minus, and so on and so forth, right? Now it's saying in a molecule of ICl, the iodine atom has oxidation number X and chlorine atom has oxidation number Y. Now you know chlorine is more electronegative. This should be -1 and this should be +1. And even if you did not know this, he's saying that iodine is reduced. If iodine is reduced, iodine here has an oxidation number of 0. How will it be reduced? Well, it will be reduced if it goes from +1 to 0. Iodine would be reduced, right here. But if this were to be -1 and this would go into 0, then it would be oxidized. So that only makes sense to give this +1 and this -1. Although you should know that chlorine is more electronegative than I, therefore chlorine is -1 and I is +1. Now, he's saying which statement about the value of X or Y is correct. So he's calling iodine atom's oxidation number X, and he's calling this Y, right? And he's saying which statement is correct. So X is the same as oxidation number of Cl in the chlorate ion form when chlorine is added to cold NaOH, hot NaOH. Let's do this, right? So we know that if you have NaOH and you add chlorine to it, what forms? Cold NaOH में क्या होता है? Cold में you get ClO minus, right? So you get NaCl plus H2O plus NaClO. This gives you the oxidation number of +1 because it's cold. See, Na and Cl forms NaCl, NaCl and this O forms NaClO, and H2O is formed, right? But if it's hot, then it takes out the maximum oxidation number of chlorine in the chlorate ion. So it's NaCl forms, H2O forms. These are two the same, but instead of forming NaClO, it forms NaClO3 because now you have the chlorate ion. You want the +5 oxidation number instead of +1 because it's hot. Hot takes out a higher oxidation number. Isn't that true? We've already studied it. So what's the oxidation number here? It's 0. This is +1. This is 0. And this is +5. Now what is he saying? He's saying X is the same oxidation number. X is +1. So he's saying this +1 is the same oxidation number of chlorine in the chlorate ion in this chlorate ion right here, when chlorine is added to cold NaOH. So when you add chlorine to cold NaOH, absolutely the chlorate ion Cl is also +1 and this is also +1. So the correct answer is therefore A. And all the others are wrong. He's saying when X is the same as when it's added to hot. No, hot is +5 and you are saying +1. So that's wrong. Y is the same oxidation number of Cl. So this -1, he's saying that this -1 is equal to the Cl in chlorate ion. No, this -1 is neither equal to +1 nor equal to +5. So this is also wrong and this is also wrong. Got it? Next, which statement is correct? An ammonium ion is basic due to the lone pair of electrons. Now this is a good question. This is a good question, but some questions don't require you to have certain knowledge because you will study it in chapter number 9, which is acid, bases, and salt. But if you remember just a little O level in IGCSE, you know that ammonium ion is not basic, is it? Ammonium ion is what? Acidic. And I've also taught this in nitrogen and sulfur, but you'll learn more about this in acid, base, and salt. It's acidic. Ammonia is basic in nature. Ammonium is acidic. So A is wrong. Nitrogen monoxide reacts with peroxyacetyl nitrate to produce a abscess. See, this is why I've taught you guys the concepts. This is absolutely wrong. Nitrogen ke oxides react with volatile organic compounds to give you peroxyacetyl nitrate. They give you peroxyacetyl nitrate, which reacts with certain other gases and forms smog like ozone vagara, and whatnot. So NOx does not react with PAN. NOx does not react with peroxyacetyl nitrate. No. It does not react with it. Rather, it reacts with volatile organic compounds, which are unburnt hydrocarbons, to give you PAN, which gives you smog. So please, this reacts with this to give PAN. PAN gives smog. So it does not react with this to produce a component of photochemical smog. So clear, such clarity in concepts is very important. Nitrogen dioxide catalyzes, yes, the oxidation of atmospheric sulfur dioxide. We know nitrogen monoxide or nitrogen dioxide both catalyzes atmospheric pollution of sulfur dioxide, because nitrogen monoxide reacts with half oxygen to give you nitrogen dioxide, and sulfur dioxide reacts with NO2 to give you what? To give you SO3 plus NO. Now some of you might think that NO is the catalyst because NO was used but reacted here, but please understand that even NO2 is a catalyst. Why? Because the moment NO2 starts to get used up from here, more NO2 is made. It's equilibrium, more, and it's a reversible reaction. So the moment NO2 is used here, more NO2 starts to be made. So NO2 is also a catalyst and NO is also a catalyst, because the moment it's used up to give you NO2, they react to give you more NO. So both nitrogen monoxide or dioxide, both are catalysts. So C is absolutely correct. Nitrogen is very unreactive due to the strong permanent dipole. No, absolutely BS. First of all, nitrogen does not have any permanent dipole. N is triple bonded to N. It's a non-polar molecule, first of all. Second of all, it is not very strong due to the dipoles. It is strong because of this triple bond. It has a sigma bond and 2 pi bonds, which is far stronger than just a single sigma bond or just a single sigma and a pi bond. So that's the correct option, and that's it.